Let's find the eigenvalues of the matrix A. We set the determinant -1 minus lambda, 3 minus 6, and 5 minus lambda equals 0. The determinant is -1 minus lambda times 5 minus lambda minus 3 times -6 equals 0. -1 minus lambda is plus lambda, minus lambda 5 is minus 5 lambda, minus lambda is plus lambda squared, and minus 3 minus 6 is 18. Lambda squared minus 4 lambda plus 13 equals 0. We use the quadratic formula, minus b plus minus root of b squared minus 4ac over 2a. Here b is -4, so that's 4 plus minus, that's 16. Minus 4 times 13 times 1, that's 52, over 2 times a, 2 times 1. So lambda equals 4 plus minus root of -36 over 2, and since I squared is -1, root of -36 is 6i. 4 plus minus 6i over 2, or 4 over 2 plus minus 6i over 2. So the eigenvalues are 2 plus minus 3i. So lambda equal 2 plus minus 3i are the two eigenvalues. An eigenvector for this eigenvalue is the following. We had -1 minus lambda, 5 minus lambda, and 3 -6. So -1, 3, -6, and 5 minus 2 plus 3i. Here 2 plus 3i. -1 minus 2 is -3. Minus plus 3i is -3i. And this is 3. This is -6. 5 minus 2 is 3. And minus plus 3i is -3i. Let's switch row 1 and row 2. So we have 3 minus 3i, that's 0, minus 3 minus 3i, minus 6, and divide row 1 by 3 to make it 1. So row 1 by 3 is 1, 1 minus I, 0, minus 3 minus 3i, minus 6, 0. To make this 0, we can do row 2 plus 3 plus 3i row 1. So that's 1, 1 minus I, 0, minus 3 minus 3i plus 3 plus 3i times 1, that's 0, and minus 6 plus 3 plus 3i times 1 minus I, 1 minus I, that's minus 6 plus 3 times 1 is 3, minus 3i plus 3i minus 3i squared. Again, remember I squared is -1. Minus 6 plus 3, that's minus 3. Minus 3i plus 3i, that's 0. And I squared is -1, so minus 3 times -1 is plus 3. So that's 0. So we have 0 and 0. Now let's solve the system. We have x1 plus 1 minus I x2 equals 0. So x1 equals minus 1 plus I x2, and x2 is a free variable. So an eigenvector for the eigenvalue 2 plus 3i is, if you pick x2 equal 1, we have 1 for x2 and minus 1 plus I for x1. Minus 1 plus I, 1, which can also be written as a vector plus I times another vector. The first vector is minus 1, 1, and the second is 1, 0, because this one is 1 plus 0i. Call this vector A and this vector B, and this alpha and this beta. So what is the general solution? It's YH equals C1 A alpha t A cos beta t minus B sine beta t plus C2 A alpha t A sine beta t plus B cosine beta t. Alpha is 2, so we have 2, 2. Beta is 3. So B is 1, 0. A is negative 1, 1. Negative 1, 1. 1, 0. Okay. This is minus, this is plus. So we have YH, which is C1 e to t minus 1, 1 cosine 3t minus 1, 0 sine 3t plus C2 a to t minus 1, 1 sine 3t plus 1, 0 cosine 3t. Can simplify this. C1 e to t minus 1 times cosine 3t, it's minus cosine 3t, and minus 1 times sine 3t is minus sine 3t. 1 times cosine 3t is cosine 3t, and minus 0 times sine 3t is 0. And plus C2 e to t minus 1 times sine 3t is minus sine 3t plus 1 times cosine 3t, and 1 times sine 3t is sine 3t. 0 times cosine 3t is 0. So the final expression of YH, the homogeneous solution, C1 e to t minus cosine 3t minus sine 3t plus C2 e to t minus sine 3t plus cosine 3t. That's for Y1H. And for Y2H we have C1 e to t times cosine 3t plus C2 e to t sine 3t.